We love to think of Earth as the absolute perfect paradise for life. But if we are being completely honest, our home planet is actually quite average. Massive parts of Earth are hostile. Frozen blocks of ice, burning deserts of sand, or pitch-black ocean depths where almost nothing can survive. But what if Earth is just the bare minimum? What if somewhere out there in the dark cosmos, there's a world so perfect that life does not just survive, it explodes? A world with so much biodiversity that Earth looks like a barren wasteland by comparison. As our telescopes peer deeper into space, astronomers have discovered a strange new class of exoplanets called super-Earths. These are rocky worlds larger than our own, and the data suggests some of them might be superhabitable, far better suited for living organisms than Earth could ever be. Today, let's use real physics and biology to build the ultimate home for life. Welcome to Hestia, the most comfortable planet in the universe. Every great planet needs a great star. Our sun is a yellow dwarf, and while it works well enough, it has a major design flaw. It dies young. Yellow dwarfs live for about 10 billion years, and they get hotter as they age. Sadly, 70% of Earth's habitable window has already passed. In just 1-2 billion years, our oceans will boil away, ending all life. What about red dwarfs? They make up 70% of all stars in the galaxy and live for trillions of years. That sounds great, but they have a dark side. Because they are dim, planets must orbit incredibly close to stay warm. This causes tidal locking, freezing one half of the planet in eternal darkness and baking the other in endless heat. Plus, young red dwarfs blast their planets with deadly radiation. The true champion of the cosmos is the orange dwarf, K-type star, sitting perfectly in the cosmic middle ground. They emit stable energy and minimal radiation. Most importantly, they live for up to 70 billion years. Our planet, Hestia, orbits a stable orange dwarf born 3 billion years ago. This leaves tens of billions of years for evolution to play out.
Let's look at the physical blueprint of Hestia. It is a super-Earth, boasting a radius 1.3 times larger than Earth. This seemingly small increase grants Hestia roughly 70% more surface area, meaning vastly more room for ecosystems to develop. Hestia possesses nearly twice the mass of Earth. Because of this massive bulk, its surface gravity is 20% stronger. If you visited Hestia, you would instantly feel 20% heavier. Walking would require extra effort, and your muscles would have to work harder. But a giant rock alone is just a dead desert, like Mars or Venus. To bring Hestia to life, we need to activate two vital internal engines. First, deep inside Hestia, a massive metallic core spins rapidly within a hot, liquid mantle. This dynamo generates a powerhouse magnetic field. This shield acts as a cosmic umbrella, protecting the surface from deadly solar winds and cosmic rays that would otherwise strip away the atmosphere. The second internal engine is active plate tectonics. Without moving plates, a planet dies. Look at Venus. Its crust is locked solid, trapping internal heat until the entire planet explodes in global, apocalyptic volcanic eruptions, creating a 470 degrees Celsius greenhouse hell. On Hestia, the crust is broken into many active, shifting plates. As these plates slide beneath one another, they act as a natural planetary thermostat, burying excess carbon dioxide deep underground so the world doesn't overheat. Simultaneously, volcanic activity pushes vital minerals, water, and life-essential elements back up to the surface. To keep the climate stable over millions of years, Hestia possesses a moderate axial tilt, giving it gentle, predictable seasons that drive migration and evolutionary pressure. We will also give it a comfortable 36-hour day and a system of 4 small moons locked in a perfect orbital dance. These moons provide gentle tidal movements and prevent the planet's axis from wildly wobbling.
Earth has a massive geographical flaw. Its land is clumped into giant continents. The centers of these mega land masses are thousands of kilometers away from the ocean, creating dry, barren, and hostile deserts. Hestia solved this completely. Instead of massive continents, its fractured tectonic plates create an archipelago world. Imagine a planet covered by a few dozen small land masses and millions of diverse islands. There are no inland deserts here. Every single piece of land has direct access to life-giving water. Furthermore, Hestia is a warm paradise with an average global temperature 5 degrees Celsius warmer than Earth. While 5 degrees Celsius sounds small, it changes everything. Earth's tropical rainforests hold more biomass than any other land ecosystem, yet they cover only 10% of our land. Hestia is almost entirely tropical. Its poles are completely free of ice, replaced by lush green wetlands. With millions of isolated islands, evolution has millions of isolated laboratories to create wild, ultra-specialized species. Because Hestia orbits an orange dwarf, the sunlight is slightly redder and fainter than Earth's. To capture this specific wavelength of light, the plants here are not green. They have evolved dark, deep shades of purple and black to absorb every photon. But the real marvel of Hestia is its atmosphere. Thanks to its high gravity, Hestia holds onto gases tightly. Its atmosphere is incredibly thick, with 1.5 times the atmospheric pressure of Earth, packed with high levels of oxygen. On Earth, high oxygen causes devastating, dry wildfires. But Hestia's warm climate creates constant evaporation and heavy rain, keeping wildfires small and manageable. This thick, oxygen-rich air changes the rules of biology. Creatures that breathe through their skin can grow to massive sizes. Giant, multi-legged alien organisms dominate the islands. More importantly, high oxygen fuels high-speed metabolisms. Predators attack with explosive power, and prey flees with incredible speed.
On Earth, flight is hard. It requires an immense amount of energy to stay aloft in our thin air. But on Hestia, the dense atmosphere makes flight incredibly easy. Even though gravity is stronger, animals need only tiny wings to glide effortlessly through the sky. Over billions of years, thousands of evolutionary branches have taken to the air. The sky is a fully inhabited ecosystem, filled with massive flying creatures that spend their entire lives in the clouds, never touching the ground. Now look at Hestia's oceans. Earth's oceans are terrifyingly deep, averaging 3,700 meters. But sunlight only penetrates the top 200 meters. This means 95% of Earth's oceans rest in permanent, freezing darkness, a massive biological desert. Hestia's oceans are designed differently. They are shallow, averaging only 100 to 200 meters deep. This means virtually 100% of Hestia's seabed is bathed in golden sunlight. Massive coral-like structures form living underwater metropolises spanning thousands of kilometers, fueled by constant photosynthesis.
On Earth coastlines, where land and ocean meet, make up just 7% of the marine environment, yet they hold over half of all ocean life. Because Hestia is an island world, Its coastlines are 45 times longer than Earth's. While our average planet hosts roughly 9 million complex species, Hestia's endless coastlines, sunlit oceans, and tropical islands could easily support hundreds of millions of distinct species. With this much biological diversity, intelligent life would likely evolve not just once, but multiple times in parallel. Imagine a world where completely different intelligent species build civilizations at the same time. How would they view the universe? If they looked out at Earth, they wouldn't see a paradise. They would see a cold, harsh, half-frozen desert planet with a short-lived star. They might look at our solar system and decide that space isn't even worth exploring. We do not know if Hestia is out there, but according to the laws of physics and chemistry, it absolutely could be. Somewhere around a quiet, long-lived orange star, the true crown jewel of nature might be waiting.